On September 23, 1999, a Mars mission that cost $327 million burned up in the Martian atmosphere. The cause was not sabotage, it was a unit conversion. One team's software spoke in English units, another team's assumed metric. And the same class of bug is hiding in how your AI agents ship code today. First, an honest number. That $327 million was not the price of one spacecraft. It was the whole Mars Surveyor program. $193 million for development, $92 million to launch, and $43 million to operate, covering both the orbiter and its sister lander. The orbiter by itself cost roughly $125 million. We say program, not spacecraft, because the number should be honest. So what was actually lost? The Mars Climate Orbiter launched in December 1998, a weather satellite for another planet. For 9 months it cruised toward Mars, built to study the climate and to relay signals from a lander arriving weeks behind it. Every system worked. The hardware was healthy. But the path it was flying was quietly wrong, and had been wrong for months. On September 23rd, the orbiter fired its main engine to slip into orbit, then passed behind Mars, exactly on schedule. After that, the signal was supposed to return. It never did. The spacecraft had dropped far too low, into the atmosphere, and was torn apart or thrown back into deep space. Mission Control sat waiting for a radio tone from a spacecraft that no longer existed. Here is how far off it was. The plan put the orbiter's closest approach at 226 kilometers above Mars. The lowest altitude engineers believed it could survive was 80 kilometers. The path it truly flew brought it down to 57 kilometers, well beneath the line where a spacecraft lives or dies. It arrived about 170 kilometers lower than anyone intended. The whole failure lived in one file. At Lockheed Martin, ground software nicknamed Small Forces calculated the tiny pushes from the spacecraft's thrusters and wrote them into a shared file. The specification said those numbers had to be in Newton seconds, the metric unit. Instead, the code wrote them in pound force seconds, the English unit. The file looked perfectly valid. Every value in it was simply the wrong size. Downstream, at the Jet Propulsion Laboratory, the navigation software opened that same file and trusted it completely. It read every value as Newton seconds, exactly as the specification promised. But 1 pound force is about 4.5 newtons. So every thruster push was counted as roughly a quarter of its real strength. Nothing crashed. Nothing raised an error. The math just drifted, quietly, for 9 months. And here is the part that should stay with you. The interface specification already required metric units. The contract existed, it was written down. In the investigation board's own words, the specification, which was not followed, defines both the format and the units of that file. The rule was correct. The rule was documented. And nothing in the entire pipeline ever checked whether anyone obeyed it. The bug also had 9 months to be caught. Navigators did notice something was wrong. The trajectory kept pointing to a path closer to the planet than expected. But those concerns were only reported casually, and they were never resolved. The team traded emails instead of filing a formal anomaly report. In the board's own phrase, the problem slipped through the cracks. Nobody was overruled. The signal just never crossed into action. But blaming one unit slip would be too easy, and the board refused to. It named the unit's error as the root cause, and then listed 8 contributing causes around it. The verification process never checked the ground software. Teams did not raise their concerns effectively. The navigators were new to this spacecraft. The handoff from development to operations was never fully engineered. The unit's bug was the spark. The system was the kindling. So here is the reframe, and it is the whole point of this story. Trust the contract, not the agent. A specification only prevents the failures that something actually checks. The metric units rule was written down. Everyone agreed to it, and it still destroyed a spacecraft, because being documented and being enforced are two completely different things. A contract that nobody validates is just a comment. So what would have saved it? Not smarter engineers. A gate. Picture the same pipeline with one thing added. Before navigation ever reads that file, a validation step checks it against the specification. Are these values really in Newton seconds? Do they fall in a physically reasonable range? If yes, they pass. If not, The pipeline stops and raises an error, loudly, in 1999, not 9 months later out at Mars. Now bring this into your world. An AI agent hands you a block of code, a data payload, a database query. It is fluent. It is plausible. It looks exactly like what you asked for, just like that file full of neatly formatted numbers in the wrong units. The agent is confident by default, and most pipelines pass its output straight downstream, assumed correct, checked by nobody. That is the Mars orbiter, running in your terminal. Here's the modern version of that missing gate, in about 10 lines. You write a schema, a contract that says what valid output must look like. This field has to be present. This unit has to be Newton seconds. This number cannot be negative. Then you validate every agent response against it before your code trusts a single value. If the output breaks the contract, it raises an error instead of flying all the way to Mars. It helps to be precise about the difference. Documented means the rule exists somewhere, in a design doc, a code comment, a prompt. Enforce means something fails, automatically and loudly, the moment reality drifts from the rule. Schema validation. Contract tests in your pipeline. Typed boundaries between systems. Mars had the left column and none of the right. Most AI pipelines today sit in exactly the same place. But be honest about the limits. Because a gate is not magic. A validator confirms the shape of the data, not the wisdom of it. A number can sit perfectly inside the allowed range and still be wrong. The contract itself can be missing pieces, or drift out of date as the system changes. And some decisions are judgment calls that no schema will ever capture. Validation narrows the failures. It does not erase them. And you should know when to skip it, because not every boundary deserves a contract. A throwaway script you run once. Output you read line by line yourself. A prototype headed for the trash tomorrow. Wrapping those in schemas is just friction that slows you down. The gates earn their keep at the boundaries where wrong data flows onward, out of sight, into another system, another team, or a spacecraft you can never reach again. There is one final, sobering Coda. 10 weeks after the orbiter was lost, its sister spacecraft, the Mars Polar Lander, went silent too, during its own descent. A completely different bug, but the same program that produced our $327 million figure. 2 spacecraft, 1 budget, 2 failures that nobody caught in time. The lesson was never really about Mars. It was about the gap between what we write down and what we actually verify. So, the architect's lens. 3 things to carry out of this. 1. A documented rule that nothing enforces is not a safeguard, it is a comment. 2. Treat every answer from an AI agent as not yet trusted until a schema or a test has proven it. 3. Put your gates where wrong data flows onward out of sight and skip the boundaries that do not matter. If autopsies like this one are useful to you, subscribe. That is the whole ask.